we are not alone. Maybe. Not in an aliens from outer space sense. We're talking about something much bigger. Bigger than planets, stars, galaxies. We need to travel back in time to the very birth of our universe.
It's the longest standing, unresolved major problem in physics, and we have the potential solution to it. We have to think out of the box and readjust our thinking to what is really happening in the universe.
Whatever this tool in the hand of man will produce depends entirely on the nature of the goals alive in this mankind.
My idea is that this universe is not the only one. There is another universe, as it were, the other side of the Big Bang. I've been interested in these fundamental questions for a very long time, and one of the things that has been of great interest to me is what is called the arrow of time.
Generally speaking, the arrow of time describes our sense of time passing. Events always seem to happen in the same order. They never go backwards. Current thinking suggests it's all related to the second law of thermodynamics, or more specifically, entropy, the order of atoms that make up all matter in our universe. This law states that the amount of entropy, or disorder, will always increase. A burning match is a great example of its atoms going through this process. It will never unburn. But how does the arrow of time lead to a theory about an entirely separate universe?
The scientific problem for 170 years is that the laws of nature do not distinguish a direction of time, at least not the ones that are really relevant. But all the phenomena that we observe around us just have one direction. We all get older in the same direction, all the stars get older. How is that to be resolved?
Julian and his team started by looking at our universe in its entirety. If the laws of physics say time can flow both ways, is entropy and its growing disorder the real puppet master of our universe? Where does time move in another direction?
Are we to believe that that is disorder growing? You know, entropy is the growth of entropy. This is what people say, the entropy of the universe is increasing. So, I mean, it's so manifestly something very interesting structure is forming. Where is the disorder in that? And I think people just haven't realized it.
So as cosmologists, what we do is we apply Einstein's theory of relativity to the universe as a whole. And typically, we talk about this in terms of an expanding universe. So if we look at the equations that tell us what happens tomorrow, we say the universe will be a bit larger tomorrow than it is today. However, that invokes an overall notion of size. You have to give the universe a size in order to make sense of that. What I'd been trying to do and trying to understand was that initial choice was essentially arbitrary, and so could we step away from it in terms of our descriptions and describe things only in relational terms?
Julian's team decided to put entropy, disorder, and the overall size of our universe to one side, and begin looking at how only gravity may affect the structure. It was turning into a battle between the second law of thermodynamics and Newton's law of universal gravitation. Could this unlock the mysteries of time? A problem from the past lay ahead, paradoxically.
When we look at the Big Bang through the lens of cosmology, we get to a point at which our equations stop working. So Einstein's theory, which is the best understanding we have of relativity, the best understanding we have of the geometry of the universe, actually is unable to process beyond that point.
But their mathematical simulations with gravity discovered that it would create a moment where a confined system of particles, such as our universe, would eventually be pushed tightly together, with some interesting results.
It was the first model which showed that you could get asymmetric behavior from a law which was symmetric. And that solution in the Newtonian picture, it starts off in the infinite past with a huge size. The particles all get closer to each other, gravity pulls them together, they come down to a minimum size, and then they fly apart again and the system gets infinitely large.
The entire picture was something quite startling. The results also suggested a way through the Big Bang.
And what we found then was this continuation was completely described by Einstein's equations for the shapes, which evolved happily through the Big Bang and out of the other side.
Now, in the normal Newtonian way of thinking it, there's just one time going all the way through, like that, from this end to that end. But actually, it's completely arbitrary. You could just as well say time's going that way, and there's no way to choose between them. However, what I realized, if you take that central point, which I call the Janus point, like the Roman god who looks in two directions at once, you could say, if I look at how the structure is changing, there are two arrows of time. One goes this way and one goes that way.
So, if all the simulations point to another universe with its own arrow of time, what would it look like?
So if there's a kind of a Janus point that spawns these two different universes, there would be a kind of continuous line between them. But it's the kind of line which I think David calls kind of parameter time. So there's kind of time as we experience it, which has this asymmetry, this future-past distinction. And whilst it looks like at the Janus point there's kind of two futures pointing outwards, nonetheless there's sort of a kind of a timeline that goes between them.
Any intelligent being, an observer within the universe, must be on one side or other side of the Janus point. So they will think that's their direction of time. They can't see through to the universe that's on the other side of the Janus point. It's there, but they can't see through because it's also chaotic there.
We then went on to say, what kind of universe would this look like? It looked like a qualitatively similar, so very similar laws of physics, will be things like stars and galaxies and so forth, but a quantitatively distinct universe from our own. So, for example, there wouldn't be a mirror image of me or something existing in this universe, but there would be very similar objects which we find in our own.
Now the final hurdle. Just how could they prove this theory right? If gravity does govern our arrow of time and that of another universe, what does it all mean?
The mathematics is right. What we might be able to do is make a very strong prediction of what the universe is like at the Big Bang, and from that, using Einstein's theory and also quantum mechanics and things, to say what the universe should be like in more precise detail than people currently realize. Perhaps in 5 years, we might have made that breakthrough to make some theoretical prediction, which people would then take seriously. They then might plan to launch a space probe, which would make very detailed observations, and then say, yes, it is right.
So I think the reaction that people would have if we were to discover this kind of dual universe, I think that there's been other cases where there's been these sorts of discoveries. So for instance, some people think that the best way to understand quantum mechanics is in terms of there being kind of many worlds. And so on that view, there's all these other kind of possible universes that again, we can't kind of causally interact with. It doesn't really change how we kind of act in our everyday life.
The work of Julian and his team continues, and other scientists around the world are working on similar models. So we await the next chapter in this tale of long-lost siblings stuck on different sides of time. But perhaps we should leave the poetry up to our scientists.
To me, when you have a new theory, when you have a new area to look at, it's like you've got a new toy or a new game. And of course, you know, if you're nice and your parents teach you well, you learn you should also share your toys with others, and it's much more fun to play with other people.
What makes a good story? Something that develops organically and so forth. And I think what our theory does emphasize is that the universe is an organically growing story. It starts from a chaotic fog and it gets richer and richer. So it meets the first criterion for being meaningful. And even if at the end of it we're all going to die, nevertheless, it's a great story as we go on. I'm thinking now of Hamlet, where he says to the actors, and he says, you should hold the mirror up to nature. If we describe nature as it is, and if it's a fantastically rich story of which we are part, we are participants, that's not such a bad state of affairs.